Welcome to The Explainer. Today, we're diving into a pretty wild theory, one that suggests a totally new foundation for reality itself. It says that everything we know, space-time, matter, energy, the whole shebang, it might all come from a single, really surprising source.
So why do we even need a new theory? Well, to get a handle on that, we have to start with one of the biggest, most frustrating problems in science today. It's a fundamental conflict right at the heart of how we describe the universe. Okay, so you've got these two giants of physics, right? On one hand, there's general relativity, Einstein's masterpiece. It's beautiful, it works perfectly for the big stuff, planets, galaxies, you name it. Then, on the other hand, you've got quantum mechanics. It's just as successful, but for the super, super tiny world of atoms and particles. The problem? They hate each other. Try to use them together, and the math just, well, it falls apart. But it gets even weirder. See, both of these incredible theories have a kind of blind spot. They both rely on these core ideas, like space-time and the act of observation, but they never actually explain what those things are. It's like building a house on a foundation you don't understand. And that massive crack in our understanding, it hints that maybe, just maybe, we're missing a whole other layer to reality. And that's exactly where this awareness theory of everything, let's call it ATE for short, steps in. It does something completely radical. It flips the whole thing on its head. Instead of starting with space-time and matter and working down, it starts with one single primitive idea and tries to build the entire universe up from that. I mean, talk about ambitious, right? Okay, so the whole theory, the entire thing, hangs on this one word, awareness. But, and this is super important, you gotta forget everything you think that word means. We're about to redefine it completely.
So in ATE, awareness is basically stripped down to the studs. It has nothing to do with consciousness or thinking or feeling. It's just the most basic distinction possible. It's the simple admission that something can be told apart from nothing. That's it. It's a structural concept, not a biological one.
Right, so just to hammer this point home, this is not human consciousness. It's not thinking, it's not feeling, it's not your subjective experience of seeing the color red. It's not biological at all. Think of it more like a fundamental property of existence itself, way, way before life ever shows up.
All right, so you've got this one primitive ingredient, this minimal awareness. The big question is, how on earth do you get a whole universe from that? Well, the theory says you only need two very simple rules, two operations that this awareness can perform. And here are the two moves in its playbook. Imagine awareness encounters two bits of information, two distinctions. It has a choice. It can say, hey, these aren't two different things. This is the same thing, just seen at two different moments. That's what the theory calls a time-like or operation. Or it can say, nope, these are two totally separate, distinct entities. And that's the space-like or and operator. And that's it. No, really, that's the entire toolkit. Identity versus multiplicity. One thing or many things. The theory proposes that these two simple choices, repeated over and over and over again, are enough to build our entire reality. So how does that even work?
Okay, this is where it gets really cool. This is the payoff. Because when you take these two simple rules and you just apply them recursively again and again and again, all of a sudden, structure starts to emerge out of what was basically nothing. It's kind of like a simple computer code that, when run, generates this incredibly complex fractal pattern.
So here's a sort of toy model of how it happens. First, you keep applying that time-like or operator. What do you get? You get identity over time, something that persists from one moment to the next. Boom, that's your first dimension, time. Then you start throwing in the space-like and operator. That creates separation, distinction. You get different locations. Hello, spatial dimensions. But what happens when these classification paths loop back on themselves and become stable and self-contained? Well, that's when you get particles.
And what's so wild about this is that the theory doesn't just say, oh, you can get three spatial dimensions and one time dimension. No, it argues that this 3+1 structure is pretty much the only stable configuration. It's the only setup that lets these little informational loops, these particles, actually hold together without just falling apart. Our universe's dimensions might not be an accident at all.
Okay, so we have a stage, space-time. But what about the actors? What about matter? If everything is just this pattern of classification, what are the actual things we see and touch? What is light? What is mass?
Well, It turns out that all these different physical things are just different kinds of paths through this informational structure. You've got a path that just zips along, preserving its identity without any effort, no cost. That's a massless particle, like a photon of light. Then you've got a path that has to constantly work, constantly redistinguish itself to maintain its identity. That effort, that cost, is what we perceive as mass or inertia. And a path that forms a stable closed loop, that's a particle, like an electron or a proton. So think about what this means for mass. Mass isn't a thing. It's not some kind of cosmic goo. It's a process. It's the ongoing cost, the classificational effort required for an identity to keep existing across time. The more complex the pattern, the more effort it takes to maintain it, and the more mass it has. It's mind-blowing. So particles like protons and electrons, they aren't the fundamental Lego bricks of the universe we thought they were. They're more like the most stable, efficient knots that can form in this informational fabric. They're the patterns that naturally emerge and sustain themselves based on the system's simple rules. Okay, I know what you might be thinking. This all sounds like really cool, really trippy philosophy. But for a theory to be taken seriously in physics, it has to do more than just sound good. It has to make predictions you can actually test. And this is where IETE goes from being a fascinating idea to potentially being hard, falsifiable science. So the theory does something incredible. It basically calculates the structural complexity, the number of these little classification steps needed to form a stable particle. It starts with the simplest one, the electron. Then it calculates the complexity for the next stable particle up, the proton, which is a more complicated three-part structure. And when you take the complexity of the proton and divide it by the complexity of the electron, what number do you get? You get 1836. Why is that a big deal? Because that number is, with stunning precision, the experimentally measured mass ratio of a proton to an electron. It's one of the fundamental constants of nature, and this theory derives it, purely from the geometry of information. No tweaking, no fudging. That's a pretty big deal. Yeah, this quote really sums up the whole paradigm shift, doesn't it? It's saying that awareness, this primitive capacity to distinguish, is the rock-bottom foundation. And the physical things we see, they're not the foundation. They're just the patterns, the structures that form within it. And that, of course, leaves us with one final, absolutely mind-bending thought. If the entire universe is just a self-observing structure, a system of awareness classifying itself into existence, then what does that make us? Are we just another one of those complex, recursive loops inside the system? Or are we the universe itself, finally waking up and becoming aware of what it truly is?